All right, welcome to this briefing. Today we're going to break down everything you need to know about waves, sound, and light for that all-important ASVAB General Science test. Let's get right into it.
So, here's our game plan for today. We're going to kick things off with the basics, then dive into sound waves. After that, we'll cover light and the whole electromagnetic spectrum. Then, we'll see how this stuff is actually used out in the field before we wrap it all up with some practice for the test.
Okay, let's jump right into our first section, the mission briefing. We're going to start with a really fundamental but super important question. What exactly is a wave?
I mean, think about it for a second. How does a submarine deep underwater in total darkness see what's around it? Or how does a fighter jet detect a target that's miles and miles away? Well, the answer to both, it all comes down to the physics of waves.
At its absolute simplest, a wave is just a way for energy to get from point A to point B. That's it. Think about ripples in a pond, right? The water itself mostly just bobs up and down, but the energy of that ripple, that travels outward across the whole pond. That's the big takeaway here. Waves move energy.
So, what happens when a wave hits something? It doesn't just vanish. It does one of two main things. It can either bounce off, which we call reflection, or it can bend as it passes through, and we call that refraction. Let's break those two down.
Reflection is something you already get. The best way to picture it is a game of pool. You know how the angle a ball hits the cushion is the exact same angle it bounces off at? Waves do the same thing. The angle in equals the angle out. Simple as that.
And you've definitely seen refraction in action. Ever put a straw in a glass of water and notice it looks kind of bent or broken? That's refraction. What's happening is the light waves slow down and bend as they travel from the air into the denser water. Our brain just sees that bent path of light and thinks the straw itself is bent.
And then there's this third one, diffraction. This is why you can hear someone talking in the next room even if you can't see them. The sound waves are literally bending and spreading out as they go through the doorway, wrapping around the wall to reach your ears.
All right, we've got the basics down. Now, let's zoom in on one specific type of wave, sound. Time for a little acoustic intel.
Okay, these points right here, you absolutely have to know these for the ASVAB. The number one thing to remember is that sound is a mechanical wave. That just means it needs stuff to travel through, a solid, a liquid, or a gas. That's why that famous movie tagline is 100% true. In the vacuum of space, no one can hear you scream. There's nothing for the sound to travel through.
I guarantee you've experienced the Doppler effect. It's that classic sound of an ambulance siren. As it's racing towards you, the pitch sounds really high, right? That's because the sound waves are all getting squished together. But the second it passes you, the pitch drops way down. That's because the waves are now being stretched out. That change in pitch, that's the Doppler effect. Okay, we've covered what we can hear. Now, let's switch gears to what we can see. It's time for some visual recon on light and the vast invisible spectrum that surrounds us.
Now this is a critical difference you have to get straight. Sound waves are mechanical. They need a medium. But light waves are totally different. They're electromagnetic. They don't need anything to travel through. They can cruise right through the empty vacuum of space, which is exactly how sunlight gets all the way to Earth.
So lean in for this one, because it's a huge concept for the test. All the colors we can see, the whole rainbow, that's just a tiny, tiny little slice of all the light that's actually out there. It's like looking at just one key on a giant piano. That entire piano is what we call the electromagnetic spectrum.
And here's that whole piano. This chart lays out the entire spectrum. Just look at the pattern. On one end, you have radio waves with really long, lazy wavelengths and low frequency. But as you move across to the other side, through microwaves, infrared, and visible light, the wavelengths get shorter, the frequency gets higher, and the energy goes way up, all the way to powerful X-rays and gamma rays. So you might be thinking, okay, this science is cool, but why is this so critical for the ASVAB? Well, here's why. This science is the foundation for some incredible military technology. Let's head in the field to see how it works.
Two of the most important pieces of detection tech out there, sonar and radar, are just perfect real-world applications of everything we've been talking about with sound and radio waves.
This chart makes the difference crystal clear. Sonar stands for sound navigation and ranging. It uses, you guessed it, sound waves. Why? Because sound travels great through water, so it's perfect for submarines. Now look at radar. Radio detection and ranging. It uses radio waves because they zip right through the air. So that's what aircraft and ships use. It's all about using the right tool, the right wave, for the job.
All right, you've received the full briefing. Now it's time for the final exam. Let's tackle an ASVB-style practice question together. Okay, read the question carefully. The key phrase here is move around obstructions. So think back to what we just covered. Is this bouncing? Is it bending by going through something? Or is it bending around something?
Go ahead and pause right here, think it over, and then hit play when you've got your answer locked in.
And the correct answer is C, diffraction. That key phrase, move around obstructions, is the exact definition of diffraction. Remember, reflection is bouncing off, and refraction is bending as it passes into a new medium. Diffraction is the one that wraps around an obstacle.
Look, here's the bottom line. Understanding these principles isn't just about passing a test. It's about recognizing the hidden physics that powers so much of our world, from a simple remote control to incredibly advanced military tech. Master these concepts, and you'll see a very positive reaction on your ASVAB score.
So, I'll leave you with this question to think about. Now that you know the principles, what other technologies can you spot that rely on these hidden properties of waves? Once you start looking, you'll see them everywhere. Your microwave, your Wi-Fi, your cell phone. Keep that curiosity going. Thanks for joining me, and good luck with your prep.